All right, we are at our final story for this month. Thank you for joining us. If you've stayed this long, I wanted to share this very interesting article that I saw scroll across on LinkedIn. It's from livescience.com, and it's a really great example of everything that we're about here on the podcast. For us and for space, I mean, if you don't know about my background, I it was not the smartest person in the room. I definitely did not know what I was doing when I got into STEM, but I got my aerospace engineering degree after a few extra tries, and I work as an engineer today. And we our 3D printing lab, like to say that we're not in STEM or living and breathing STEM every day, that would be a lie. But getting here, it wasn't because I was the smartest person. It was because I found something that I was really passionate about, and I found a solution, or I literally spend my most of my day solving problems with engineering somehow. So when I see a story like this where students are able to get involved in like a mission of space and think about this stuff. Even elementary schoolers have brilliant ideas if you allow them to think about the problem. And it's one of the things that I think is not great for STEM, and it's something that we try to counteract with what we do here on the podcast, which is that, space and science can be for everyone. If it's not, then it isn't. But if you even have a small amount of passion, or like you would like to get involved in something in space, and you're not an engineer or a physicist, there's room for you. And that's what I love about this article here in this story. So elementary schoolers prove, this is the article from Live Science, elementary schoolers prove EpiPens become toxic in space, something NASA never knew. And so it's interesting. This article kind of takes a jab at NASA that, they didn't know, and it took elementary school kids to figure it out. But this is the conundrum of space. For a very long time, we did not have all these abilities to send things to space. So there was always a game of figuring out how much money, how many missions, who gets cut, who stays. It was very hard to conduct research in space. So opportunities like this that was run through, so this is students from St. Brother Andre School Program for Gifted Learners in Ottawa were studying the effects of cosmic radiation on epinephrine, the active ingredient found in EpiPens, an emergency treatment given during severe allergic reactions. NASA selected the students' experiment to be part of Cubes in Space, its global STEM program geared specifically to school-age kids. So NASA funded this experiment, and they chose their experiment. There's more opportunities for not only science to happen, but for these kids to have an involvement. I only was able to get involved in something in space when I went for my aerospace engineering degree, and my project was on a CubeSat. I worked on a team where we worked on a CubeSat, the structural side of the CubeSat that was going to take solar weather readings. So that was definitely one of those moments that made me think I want to do this. It was one of those moments where I reached very high, and I was able to have that opportunity to be on that team. And for these kids, I can only imagine what it does for them. But then they also came up with something that's a really good piece of information to have, especially as we start going towards a future where we're going to start sending people into space regularly, and we open up the diversity of humanity to the astronaut pool. And the more and more things that we can know about how people are going to react on planet versus off planet is really, really important. So this epinephrine discovery is incredible. So for the program, the 9 to 12 year-old students design an experiment in which epinephrine samples were placed into tiny cubes and sent to the edge of space via either a high-altitude balloon or a rocket. And once back on Earth, researchers from the John L. Holmes Mass Spectrometry facility at the University of Ottawa tested the samples and found that only 87% contained pure epinephrine, while the other 13% had been transformed into extremely poisonous benzoic acid derivatives, according to a University of Ottawa statement. So, everyone got really crazy about the Chinese balloon that came over the United States. But balloons are an extremely cheap way of getting things to the edge of space. And it's done on the regular for people that are taking weather readings. There are multiple balloons released for rocket launches to check the wind shear as they're going up. It's a very tried and true way of getting to space. So if you don't have a lot of rockets out there and you're just trying to get, make it so that you can fund enough projects for enough kids to do things, setting it up in a balloon is a really, really good way of doing that. So that's what they did here. And so the cosmic radiation has extremely high energy particles, and the atmosphere that we have is really what is our blanket against that kind of radiation. But on the ISS, if we're going into deep space, these are the areas where we need to really pay attention to cosmic radiation, because high energetic particles going through you is not a good thing. And the cosmic radiation shows to have a clear impact on chemicals like epinephrine, it's quoted by Paul Mayer, a professor in the Department of Chemistry and Biomolecular Sciences at the University of Iowa. The after samples showed signs that the epinephrine reacted and decomposed, and in fact, no epinephrine was found in the after EpiPen solution samples. This result raises questions about the efficacy of an EpiPen for outer space applications, and these questions are now starting to be addressed by the kids in the PGL program. So this is awesome. I think it's so cool that these kids were able to get involved in something that's a really important answer to have, again, before we send somebody up there, because if you think about what would have been brought for someone that needs an EpiPen, the EpiPen would have been probably in the top 5 things that they need to bring with them. And now that that's not an option, or that perhaps shielding needs to be provided to these EpiPens when they go up there so that they are not exposed to cosmic radiation, we can now take that step and not find out if someone's taking an EpiPen, that's a life or death situation. You can't be giving them something that's toxic. So it's an extremely important study for all of us, and the results are really interesting. And now it makes you think, how many other things do we take for granted that if you throw some cosmic radiation in the mix, it does the exact opposite. So I thought this was an amazing story. It's another reason why open access to space and unhindered access to space for answering questions and posing hypotheses and challenging what was already known is really, really important. And even elementary schoolers can provide really in-depth and important solutions and research, just like the fact that EpiPens become toxic in space when they're exposed to cosmic radiation.